So you quite often want to write a program with multiple occurrences of the same type of thing. So imagine you write a game and it's got 10 balls in it. So you want to refer to each of those balls, so you could call them ball 1, ball 2, ball 3. But each of those balls will have properties such as its x coordinate, its y coordinate, speed, direction, etc. So you might start calling them things like ball 1x, ball 1y, ball 2x, ball 2y, etc. Very quickly it gets quite messy. You could use lists of properties, so you can have ball X and then you can have a list of all the properties of the different balls, but then you've got to cope with the indices. So another way to go about it is to use an object-oriented approach. So if you've searched for object-oriented programming on the World Wide Web, you might have come across lots of obscure examples. There seem to be quite a lot of trucs involved in explanations. So I'm going to explain how to use object-oriented approaches in Python using rectangles, because rectangles are something that we're all familiar with. So first thing I'm going to do is I'm going to use the class keyword to define my rectangle. So a rectangle, there we go. So it behaves a bit like a function definition. So I have class and then the name. And then I'm going to just indent the definition. So we can give it this class. So what a class is, it's a definition of what a rectangle is. So a class is a definition. So one of the other things that you might get confused about is the difference between a class and an object or an instance. And so I tend to think of it in terms of kind of dictionary definitions. So if I look up a rectangle in a dictionary, it will tell me what a rectangle is. It will say a four-sided shape, etc. And it will have obviously certain properties, but it won't show me an actual rectangle. So a class is like a dictionary definition of what a rectangle is, and then an instance or an object will be an example of a rectangle, and we'll have a look at how to do that in a minute. So the first thing I'm doing is I'm kind of creating a definition of what a rectangle looks like. So we can have variables in there that apply to all rectangles, in which case we just pop them at the top, and that's quite useful because what I might want to do is I might want to create a class that represents kind of a generic shape, and we'll come back to that in a separate video, in which case a rectangle would be an example of a shape but with four sides specifically. Then so that's an example of an attribute. So an attribute of a class is really just a variable. And then we also have things called methods, and a method of a class is really just a function. So we can create our own, but there are some with special names, and the special names begin with double underscore. So underscore underscore, and one we'll need for all of our classes is this one called init, which gets run when you initialize the function. So and all these special ones, and in fact all other ones you can create yourself, have this initial parameter of self, and self just tells the function which object you're actually referring to. So self just means the current one. So I don't think you have to call it self, but it's good practice to do so. So that always gets passed to any of the methods of the class. And then what we'll also include here is any attributes that we might want to include, or any parameters that we would include, just as we would with a normal function. So I'm going to say a rectangle has a width and it has a height. Okay, so when I create the rectangle further on, so I said that this is the definition. If I want to create an example of a rectangle, I can use any variable name, so I can call it A, for example, and then I'm going to say rectangle. And then I'm going to give it some properties. So I'm just going to give it the width and the height, for example. So what that will do is that will pass 3 as the width and 2 as the height. We don't need to worry about that first one, self, because self really refers to the A. So which object are we actually creating? So again, just like an ordinary Python definition, we have a colon at the end. And then what we're doing here is we're setting values of the attributes. So attributes will begin with the name of the object, so that will be in this case self. So self makes it generic rather than specifically referring to A, because this definition at the top will apply to all rectangles, whatever we call them. So self.width is the width property of the rectangle that we're currently operating with. So we're going to set that to the value of width that's passed in as a parameter, and we're going to do the same thing with self.height. So that will represent the height of the object. Okay, so that's as simple as it needs to be to begin with. So if I run this now, okay, it doesn't appear to have done anything because I haven't printed anything, but if I want to refer to the properties of A, so if I look at type of A now, it'll tell me that, well, it's telling me that it's a rectangle, and I can reference the particular properties by using the full stop. So if I say A.width, then that will tell me the width, which I've set to be 3. And if I say A.height, then it'll tell me that it's 2, which I set here. So I can access the properties. If I then create another rectangle, so this time I'm going to say this one is 4 by 3. So it's just created that. So if I say B dot width, we can see that's 4. So it's kept them separate. So one of the benefits of using objects and classes is it keeps things nice and tidy. You can use the same name for all the attributes of different objects. We can also use these properties to set the value. So if I say b.width equals 5, for example, it'll let me do that. And if we have a look at the b.width, then it will be 5. So that's the kind of basic principle behind creating these classes and then creating an object based on that class. So A is an example of a rectangle based on a rectangle class, which is my definition of a rectangle. So what else might we want to do with that? Well, we might want to perform some operations on a rectangle. And this is where the rectangle example makes more sense than trucks and other things. So what do we know about rectangles? Well, one of the things we know about rectangles is they have an area. So imagine I want to be able to determine the area of a rectangle. So I can create a function called area, for example. And what I'm going to do is it's just going to take a specific object. So that's all we need to know, which area we're talking about. And how do we calculate that? So it's going to be the width of self times multiplied by the height of self. So if we want to work out the area of A, it's going to be A.width times A.height. Otherwise, so we can do that, and then obviously because it's a function, probably want to return that. We could print it and make it a procedure, but I'm going to return that value. So now let's have a look what happens when I run that. So again, it doesn't do anything because it doesn't print anything. But now if I say A dot area, now when I'm called, this is called a method. So a function within a class is called a method. It's an action or something that I might want to do to a rectangle in this case. And because it's a function, I need to put the brackets in there, the parentheses, but I don't need to put any parameters or arguments in there. So if I say A.area, it's going to multiply the height and the width, and it's going to return the area. So a rectangle that's 3 by 2 has an area of 6. And similarly, if I wanted to do any other calculation, so if I wanted to create a perimeter, for example, function, I could do that. So the perimeter of a particular object is, it's going to be, in fact, let's just copy and paste that. So it's going to be not the product, but the sum of the height and the width, and then we need to double that because that's just 2 of the sides. So now if I run this, so A.perimeter is going to be 10 because you've got 2 lots of 3, 2 lots of 2, and that gives you a perimeter of 10. So what other things might we want to do with it? Well, we don't necessarily have to return numbers. We might want to know whether, for example, our rectangle is a square. So you might be aware from your maths that your that a square is a special case of a rectangle. So again, all we need to know is which rectangle it is we're talking about. So we could return, for example, so all we want to know here is whether the height and the width are the same. So if we say a dot square, it's going to say false because a isn't a square, it's 3 by 2. But now if we say b equals rectangle, now if we make this one 4 by 4 and we ask is b a square, it will say it's true, it is a square. So there might be lots of other different things that you might want to do. If you have a look at the link below this video, there is a link to a program that I've created in Replit, which has got a more complete set of methods that you can apply. So you can do things like enlarging, rotating, and plotting out the shape of the rectangle. So it just uses a loop to reproduce the shape of the rectangle using hash symbols, for example. So we can do that sort of thing, anything that you like in there. But what about, so if I want to know how, well, if I can't remember, so imagine I can't remember what the dimensions of A are. So I could, because on the right hand side there, it's not showing me, is it? So I could do this, I could A dot width and A dot height, but that's getting a bit of a faff. So if I just say A, it just tells me what it is. So, okay, well, that's not working. So what about if I print A? Well, that's not doing anything either. So there are more of these special functions. So we can use those in here as well. You can look up these on the internet if you want to. So one of those is one called REPR, which I assume is short for representation. So if we want to print, for example, this is the kind of printable version. So what would we want to do if somebody asks us to print A? Well, this time it's up to me. What would I want to do? What do I want to know about A? So I could print, I suppose I could print its dimensions, couldn't I? So I could say self.width times self.height. So now I need to run my program before that actually takes effect. So now if I run my program, if I do A, oops, I run my program, I type A, and what do I get? I get an error. And that's because I've printed it instead of returning it, which is what I should have done. So I'm going to return the value. So this time, what I'm going to need to do, because I'm concatenating the different parts of the strings rather than printing them using commas, so I need to turn that into a string. I need to concatenate that with an X so I can see the dimensions. I'm going to concatenate that with, again, the string version of the height. So let's run that again, and hopefully that'll do the trick. So now if I just type A, it'll tell me how big it is, or indeed if I print A, if I was in the middle of a program, it would tell me how big that is. So these things here with the double underscores, the kind of special functions to Python, they're not things that you would call directly, but they're called as a result of you doing certain things. So there's also one for the integer representation or the string representation, so if you use int or str. So what we're going to do, for example, if we use int on a rectangle, what would that mean? So if we're going to use int, what would you want that to return? Well, I suppose you could return the area, couldn't you? So if you wanted a single number, you could return self.area. So what would that run now? If we run that, so now if I print A, that still works. If I print int A, it gives me 6, whereas previously it would have given me an error if I tried to use int, because it isn't an integer and it wouldn't know how to convert it. So this
is also very useful for comparing. So if you want to compare two triangles, obviously, if we said something like, A equals 2, if we're just using ordinary variable types, and B equals 3, what we can do is things like, is B equal to A? Is A not equal to B? Is A greater than B? And is B greater than A? Remembering that it's case sensitive. So Python knows how to compare certain kind of things, so it knows how to compare strings, floating point numbers, integers, etc. But it doesn't know how to compare rectangles. So if we I'm going to put another rectangle in here. So if we said B equals rectangle, so I don't know, 3, 4. So when I run this now, I've now got 2. I've got A and B. And what about if we want to know whether A is equal to B? Well, it's saying it's not, but by what criteria is it saying that? So what about if we say is A greater than B? So it's not liking that. So we can override the standard comparisons that are available in Python with our own. So this is called operator overloading, which you might have come across if you've been reading up on object-oriented programming. So what do we want to do if we're comparing two rectangles? So so that's a greater than, isn't it? So the special function for greater than would be GT for greater than. And this, when you're doing a comparison, obviously you're comparing two things. So we're going to compare self, which is the current one, with an other function. So we're going to take two arguments here. So what is how are we going to compare whether two rectangles are whether one is greater than the other one? So this is obviously up to you as a programmer. If you created a special type of object, this might not make sense. I would say maybe compare them on area. You might say that one rectangle is greater than another one if it has a bigger area. So what we're going to say then is we'll just return whether self.area is greater than other.area. So those both are numbers. So if we return those, so self will be the first one. So in this case, A. Other will be the second one, which will be B. So is the area of A bigger than the area of B? So if I run my program now, and I've now got the value of A, and if I do A greater than B, it will say it's false because the area of A, so A.area, is 6, B.area is 12, so actually B is bigger, isn't it? So it's not true. So if I did that the other way around, if I did B is greater than A, it's true. But obviously that relies on you getting them the right way round. So there is an equivalent function called LT, less than. So we'd have self other, and then we could do one the other way around as well. So let's just copy and paste that, and obviously do it the other way around. And in fact, there is also one for equals. So equals seem to work, so I don't know whether Python was actually just converting those to the integer representation, because I've already done those. But if we did def eq for whether it's equal to, and again we want self and other because we're comparing two things, so we could return whether they are equal to each other. So now if I run this, is A greater than B? No, it's not. Is A less than B? Yes, it is. Is A equal to B? No, it's not. But let's have a look at, so A and B. So don't forget we can change these. So if I do a dot width is equal to 4, now they are the same, aren't they? So if I do A equals B, so what that tells us is, in fact it tells us that they're not the same. So A, B. So what happened there? I changed the wrong property, didn't I? A dot height equals 3. So now A equals B. That is true. Okay. So what I'm doing there is I'm comparing the height. So I'm saying two rectangles are equal if they've got the same area, but we might want to be more precise than that. So we might want to say if might want to compare the height and the width. So if the widths are the same and we want to do the same thing, if the widths are the same and the heights are the same. So now if we run that, so A and B, so let's say A dot height, let's get it right this time, is 4. So now A's A equal to B. No, it isn't like that. And that's because I've put the brackets in. So these are height and width. Whereas area was a method, so it required the parentheses, height and width are properties, attributes, so they don't require the parentheses. So let's try that this time. So A and B. So A dot height is 4. So now they are the same, A and B. And if you have A equals B, then that's true. What you might also want to determine is, or decide, is that they're the same if they're rotations of each other. So you could say self.width equals other.height, for example. You can include extra properties there. So that's equal to, greater than, less than. We've looked at the string and the integer representation, and also what happens if it's just printable. So when we're creating a class, we can give it some generic attributes. So inside in this case, all rectangles have 4 sides. We can accept some parameters and set attributes according to those. We can create our own named functions, which we call methods, which are actions you can perform on a rectangle. And then we can use some of these special ones with double underscore and prefixes and suffixes to override certain built-in Python functions, such as how we print something, how we convert it to an integer or a string, or how we do comparisons such as greater than, less than, or equal to. So that's the end of our quick look at classes. What we're going to have a look at in the next video is how we can inherit properties. So can we create a generic shape or polygon class, for example, and have rectangle as a subclass inheriting some of the properties from that.